The next problem is a really tough one. It wants us to put this in standard form and then determine the distance between the vertices. So to put this in standard form, I'm going to write negative 9x squared plus 18x, and I'm going to leave a space here. And then I'm going to do 4y squared plus 24y. And I'm going to move the 9 over to the other side, so it equals positive 9. I'm going to leave a space here, because I'm going to have to complete the square on both of these. Before I do that, I'm going to pull out a negative 9 in front here. That would leave me with x squared plus 2, or I'm sorry, minus 2. X plus some kind of space. And then I'm going to factor out a negative 4 from the next one, which would leave me with y squared minus 6y plus space equals 9. The reason I left spaces is because now I'm going to complete the square. So I'm going to add b over 2 squared to both sides to make it a perfect square trinomial. So b over 2 in this case is negative 2 over 2, which makes negative 1 squared, which is really just 1. And 1 times negative 9 is a negative 9. So I'm going to have to subtract 9 from the other side as well. That's really what I'm doing when I add 1 right here. And then here, b over 2 would be negative 6 over 2, which is really negative 3 squared, which is really just 9. I'm going to leave it as negative 3 squared right here. But then keep in mind it's really 9, and 9 times negative 4 is a negative 36, so I need to subtract 36 as well here. That leaves me with negative 9 times x minus 1 squared. This is a perfect square trinomial, so put x and negative 1 here. Minus 4 times y minus 3 squared equals, these cancel and you end up with negative 36. Now I need this in standard form, so it looks like a hyperbola so far. I'm going to divide by negative 36 though, from everything to get this to be 1. And it might be an ellipse then if these negatives cancel. So double negatives cancel here and also here. So I end up with, let me simplify this, 9 goes into 36 4 times and 4 goes into 36 9 times. So I end up with x minus 1 squared over 4 plus y minus 3 squared over 9. So this is an ellipse, not a hyperbola. And we need to find the distance between the vertices. So we need to just quickly graph this thing. For an ellipse, this one's centered at 1, 3, so I'm going to go over 1, up 1, 2, 3, which is right here. Now, the bigger number a is underneath y in this case. So typically on the formula sheet, we would write for ellipses, when the bigger number is underneath y, we usually write that first, y first, like that. But a is linked to the semi-major axis, so a in this case is 3. So we would go up 1, 2, 3 for that length, and down 1, 2, 3 up to here. So there's the distance between the vertices. Which in this case is 6. The next problem says we have a hyperbola has a vertical transverse axis of length 8, which I think that's a typo 2. This problem has a couple problems in it. For me, this didn't work, the focal length, but I'll go through it anyway. These first and third answers should work fine. But they give us 2 of the asymptotes, and they want us to find the center and the focal length and then the eccentricity. So I'm going to graph both these lines real quick, and I'll let you look at that graph then. Okay, so I've got these 2 asymptotes graphed right here. Try to graph them as good as I can so that I can draw this clearly for you. But it says that it's a vertical transverse axis, so that means that the parabola is going to go through some point up here and go vertical. The asymptotes are here, so something like this. We can find the center just by finding the intersection of these 2 lines. That's pretty easy. So just set these 2 equal to one another and solve. Now, unfortunately, I get a really ugly number here, a fraction, which I know we're not comfortable with fractions, but that's okay. It's good practice. So we're going to add 7 over 3 to both sides. It gives 14 over 3x equals, add 4 to both sides. It gives 13. Multiply both sides by 3 over 14 to get rid of this, and you get x equals 39 over 14. That's the x coordinate. That's h. The x coordinate for the vertex. To find the y coordinate, I plug this back into either one of these and find out what y is. So I'll do that now, which is 7 over 3 times 39 over 14 minus 4. 3 goes into 39 3 times. 7 goes into this twice, so it's 3 halves minus 4. So 3 halves minus 4 over 1. I'll make the common denominator 2, which makes this 8. So negative 5 halves. So my center is at 39 over 14, comma negative 5 over 2. That works fine right here. Okay, so they want us to find the focal length. Now finding the focal length is pretty tricky. It's actually the distance from the center to one of the foci, but double that, because the focal length is the whole thing. So we have to find basically that distance from the center to the foci, which is C. And we can find C by using the information that's on here. I'm going to use this right here. You know, we're talking about this column where x equals number, we're talking about a vertical hyperbola. So we're over here. So I'm going to use this and compare it to what we have. So it's A over B. So that would be h plus or minus c comma 0. I'm sorry, a squared plus b squared equals c squared. So that'd be 9 plus 64 equals c squared. Add 9, you get 73, so it's the square root of 73. So you can enter those in as order pairs, minus the square root of 73, comma 0, and positive square root of 73. Right here, comma 0. And then it wants the equation for the asymptotes, so we're going to use this equation right here. So we would have y equals, we have both the plus and the minus of b over a, so that's 8 over 3. H and k are 0, so it's just x. So do the plus and the minus of this equation, and those are your two answers here. Okay, next problem is the same one, this time y comes first. So when you look at our formula sheet, we're dealing with now the second column. In fact, oh, never mind. I thought we did the last problem wrong, but we're good. So we are dealing with the second column here, all the information there, because y comes first here. So we can find a real quick. A is 1. We can find b, it's 2. And then from there we can find the vertices. This one's not centered at the origin, so h and k is the center, which in this case is -1 comma -4 because it's x minus these things. I'm sorry, other way around. It's y minus k, so this would be -1 or -4, and this would be -1. So from there we can find the things that they're looking for. So they're looking for vertices. Vertices are right here, h comma k plus or minus a. That would be -4 comma -1 plus or minus a, which is 1. So we'd have -4 comma 0, and -1 be -2 minus -1. So here's the two vertices. You can put those right here. Next is the foci. Foci are right here, so that's h comma k plus or minus c. So h is -4, k is -1, but we need plus or minus the c value. We don't know c, so we're going to find it using this Pythagorean relation. So a squared plus b squared, that'd be 1 plus 4 square rooted, which is the square root of 5. So our 2 points are going to be -4 comma -1 plus the square root of 5. And we also have -4 and then -1 minus the square root of 5. All right. Last is the equation for the asymptotes. Equation for the asymptotes is right here at the bottom here. So it's just plus or minus, and then we have a over b, so that's 1 over 2, times x minus h, so the x plus 4, plus k, which is -1. So there's the equation for our asymptotes. Do positive and then do one negative separated by a comma. I know it's a lot to enter in, but those are our answers.